Welcome, everybody. Give myself space. Thank you for coming to the 401 Tech Bridge Advanced Materials and Technology Center to see it in its very raw form before we get started with the construction. But we're not here today. We will talk at the end of the presentation today a little bit about the space and what we have planned for it. But really the point of the day today is to talk about the new prize challenge that we are launching with the Navy. It is one I think that is really relevant to the expertise of the regional community. And so we're really excited that you're all here to listen to the details, and I hope that you will decide to either submit entries or to partner up together to create entries. I think there's a lot of room for opportunity for the local and regional community here. So I'm Mary Johnson. I'm the manager of 401 Tech Bridge. Over the course of the day today, we'll be talking a little bit about who we are and what we do, the work that we do with the Navy. And then Steve Bordenaro and Christian will take over to talk. Christian Schumacher will talk a little bit about the challenge specifically. And we have joining us via Zoom, Kelly Higgins from Incentive will talk about the platform so that you understand the application process. And then we will answer technical questions if you have any. Technical questions can also be submitted on the Incentive site. And then to close out the day, Christian Cowan and Susan Daly will talk about the construction that we're about to start in the space and kind of the vision that we have for the building going forward. So first I'm going to talk a little bit about 401 Tech Bridge. We are an organization that is expanding economic development in the region by supporting companies in advanced materials, textiles, composites, and related technology that are doing R&D, that are innovating to help you connect to new opportunities, connect to each other, and connect to resources that can help you keep your business growing. So the slide gives you a sense of all the different people that we partner with. We really look at ourselves as a super connector. We're working with resources like Christine Smith at Commerce, with Synedia, with the major universities, the CIC, the RI Hub, to really connect you into the resources that you need to continue to make your business sustainable and grow. We also are helping to identify and leverage opportunities so that we can help you, with the help of Lee Silvestri, who's in the back, connect to SBIR topics that might be relevant to you, help you navigate the system of finding government opportunities for funding and for projects that can support your R&D. And also, we partner very closely with NUIC, the Naval Undersea Warfare Center here in Newport, and we have a partnership intermediary agreement with them to help with outreach and connecting them into the small business community in the region and to solve technical problems. And one of the ways that we do that is by managing these prize challenges. And other ways that we can connect you is, for instance, if you have a gap in your R&D, and I know a couple people in the room here are already doing this, we can help you partner with the University of Rhode Island to work with university faculty and labs that can help you fill gaps in your R&D process. And so whether it's working with universities, working with government, working specifically with the Department of Defense or the Navy, we're really here to put our resources to work to help you be successful. So there's a lot of, because our names are similar, people often have a lot of confusion about what's the Northeast Tech Bridge and the 401 Tech Bridge. So I just want to spend a second to kind of clarify that. So the 401 Tech Bridge is a nonprofit. We are part of the University of Rhode Island Research Foundation, and we are a sibling to Polaris MEP. Many of you know Christian and I from the Polaris side. Our goal, as I just talked about, is really to help small businesses grow and to solve problems, to advance their R&D, to help you accelerate your technology, help you find commercial and defense applications for your technology. The Northeast Tech Bridge is a Navy entity. It was created by NavalX. there are 16 tech bridges across the country and in London, and they have very similar goals. They want to partner with innovation partners, and that's people like 401 Tech Bridge, to accelerate solutions to the warfighter. Steve will tell you later. I think that what the Navy has discovered is that there's a lot more innovation going on outside the gates than inside in some cases, and they want to be able to connect to the innovation that's happening outside the gates. So 401 Tech Bridge as a nonprofit helps connect them into companies and connect companies into the Navy, and the Northeast Tech Bridge can connect into the larger Navy network very well, and to the Navy tech bridges around the country and in London to really tap into the expertise and technical needs of the different divisions across the country. So they're tapping into the bases. We are both sharing resources in academia and industry, and we really work collaboratively to make sure that there's a lot of good things happening for companies. So this, which is hard to read on this wall, just gives you a sense of the Venn diagram of the Navy and the Northeast Tech Bridge doing the really governmental things, contracts, and creating topics for SBIRs, creating partnership agreements. And then we're on the other side with, we can help with tech scouting and proposal supports, helping you find non-Navy sources of funding. And then in the center, we have things that we share. We both have developed state and local partnerships. We're doing outreach together. We're working on prize challenges together. So when you get this slide deck, you can take a closer look at this. It gives you just an idea of the, like I said, as Lee likes to say, we walk hand in hand with a lot of things, but we both have independent responsibilities. And as long as we maintain our independence, we're doing the non-Navy things as well as supporting the Navy, and then the Navy is really focused on their responsibilities within the government and the Department of Defense. So one of the things that we have been helping with are the prize challenges. We have one that's just about to close that is to create a system to better 3D print hand wheels on ships. And then we have the one that we're about to launch today, and then we have a couple in the pipeline, so you'll be hearing more from us about prize challenges soon. But the idea behind a prize challenge is really to crowdsource a solution to a problem that they're looking for different ways and different approaches to. So we're trying to achieve a goal. We're looking at a very specific timeline to get responses, and then they'll be evaluated, and then there will be cash award to the company that best meets the requirements, or who meets all of the requirements in the best fashion. And they really use it as an opportunity to reach out to non-traditional solvers. So it may be companies that are applying that haven't typically worked with the DoD, who are looking to get some visibility. It may be individuals who are innovators or entrepreneurs who are looking to get a business started. And oftentimes it may just be people who were in related fields who have knowledge that crosses over, and they're enjoying the opportunity to be part of the problem-solving process. So as we go through the day today, you'll hear more about Incentive, the platform that we've partnered with to help manage the prize challenges. And they have a global network of solvers, they call them, who are working on individual challenges. But you'll also understand how you could apply if you're interested in submitting a solution to this challenge. And so now I'm going to turn it over to Christian and to Stephen, and I'll let you guys talk more specifically about this challenge.
Great. Thanks everybody for coming in. My name's Christian Schumacher. I know some of you. I recognize some faces in the crowd. I come from a unmanned undersea vehicle background, power and energy. I worked with local companies like Yardney or Eagle Pitcher doing power and energy, chemical engineer, and I've jumped recently, about 18 months ago, to the other side of the problem to look at counter UV, and that's really the motivation for this prize challenge. It's an emerging field. I do a lot of different things, but you can see here, Narragansett Bay Test Facility. This is where most of our work is out of, the Connex box. Some of you may be familiar with that with Antex. I was also deputy for Antex a couple years ago, and I got to know a bunch of folks through that. Next slide, please. So here's an OV1, and I'm going to do everything I can at the unclass level, but feel free to ask questions, and if I can answer, I will. This is what we call in the Navy OV1, Overview 1, cartoon of what it is we're trying to do. And what you see here is a generic pier. In this case, we actually have some submarines on it. And we have different threats, which are usually dictated as red threats coming in. All the blue assets are our Navy's assets. So we are playing Blue Harbor Defense against various different threats. A lot of this work came out of counter diver work. And when you think of what we would have to do to counter a diver coming in to attack some high-value asset for the Navy, you can see it spelled out on a kill chain across the bottom of this slide. So detect, track, classify, and defeat, which could be lethal or non-lethal. And as we start to think about some of these challenges of threats coming in, if you have been at MBTF, there's a jetty breakwater there. That's almost exactly 1,000 meters. If you went on Google and looked up diver detection sonar and saw what was marketed right now, their range is about 1,000 meters. That gives you a scale if you have been on our campus. So when you think of laying out a framework of the problem, a diver could be detected at roughly 1,000 meters outside the breakwater, coming in at 1 knot. You have about a half an hour to decide what you're going to do against that diver. I'm also a Navy diver. I've done that dive hundreds of times. I'm about a half an hour to come in and do that dive. So classic threats like that, you have a lot of time to respond. As we think of new emerging threats like unmanned undersea vehicles, they're coming in at 2, 3, 4, maybe up to 10 knots. So that response time drops down inversely. So maybe your response time is an order of a couple minutes. So what can we do to counter these new emerging threats? And one of the thoughts is push our detection range and our sensors further out. So if there's some way to get these sensors mobile and further out into the harbor, they would be able to pick things up at a further distance out. So that's sort of the motivation of this prize challenge. Next slide. And I'm going to hand this off to Dr. Steve.
So after talking to Christian and working with his team on a piece of this problem, when we started discussing what we could do to extend the range, we said, well, it'd be great to have an unmanned surface vehicle. But if the system needs to be flown to a harbor or going to some place where we need to protect quickly, it's a lot easier to get that system out there if we just had it in a shipping container. If you look at some of the requirements we think that unmanned surface vehicle would need, it's not necessarily going to be able to be done with a small Boston whaler or something that could fit in the shipping container. So he said, yeah, we really need some innovation here, and let's try to reach out to people who don't usually play with the Navy. When we talk about innovation in the S&T world, the Navy does, and inside the gates of Newark, a lot of good innovative projects. For example, 10 or so years ago, you might have seen jet skis swimming around without a driver. We were doing unmanned jet skis, developing that technology. But when you get that to a real system and you have to go out to industry, that's where we're kind of slow. We're not necessarily dealing with the fast-moving companies out there. And now when you see that there's racing marks that are being run by GPS by a company that makes these unmanned marks, you say, those are the companies we need to be working with, not the big players for the innovative stuff. They'll still have the big contracts, they'll still make their money, but we need to be able to play with the smaller players, the innovative companies, to move quickly. So for this particular problem, what could some companies come up with? So as Christian did a great interview with the big picture, want to focus on that word expeditionary. So that means we might be going to a harbor where we're not set up. It might not be a Navy harbor. It could be a safe place for us, but we're not really set up to protect an asset. We got to get the system out there quickly and get it up and running quickly. It's a system that we want to be able to use multiple times, and it goes out, we unpack it, we put it together, and we bring it back home. So you need to be able to, if it doesn't just fit, if everything doesn't just fit in the box, you need to take out and assemble it at the point of need, and you have to do that pretty quickly. And as I mentioned, we're looking for novel designs for this unmanned surface vehicle that could be put in a 20-foot container. You either press a button, it inflates, or you unfold it, something along those lines. It becomes the size you need for the payload, and you have to do that in about 2 hours. And we'll get into some of the payloads after. So again, just kind of looking at the cycle of what you need to do with the system. It's in a shipping container. You throw it on a trailer. do whatever assembly you needed to do, and suddenly it's something that's out in the water that can do the mission, and then it goes back in the trailer. The trailer could be a standard trailer, or it could be something that is designed and built into the USV itself, if you're worried about some of these size constraints. We'd like to be able to fit one trailer and two USVs, but the minimum requirement is one trailer and one USV. One important thing to note, there's no requirement to support manning on the vehicle, even optionally. So when you're in your design space, you don't need a cockpit, you don't need a steering wheel, you just need the vehicle itself. So payloads. We have some examples of the payloads. I'm going to have Christian be my Vanna White on this. But I'll talk about the I'll talk about the autonomy payload first. We considered making this challenge including the autonomy piece of the USV, but we decided that would be too limiting. So what the Navy will provide is an autonomy system to plug into this vehicle. For the design step that you guys are going to do, you don't really have to get too much into the details of interfacing with this autonomy, but there are commercial systems available. We're not guaranteeing that we'd use a particular one, but the one shown is Sea Machines up in Boston has this SM300, which they duct tape it to a boat and suddenly it's autonomous. Maybe it's not duct tape. I'm an electrical engineer, so I think everything in the mechanical world is duct tape. It may or may not be true. It's zip ties. Yeah, if this is a duct tape and zip tie boat, I'm all in. So that payload will be attached. We don't have an example of that. As I go around the system clockwise here, we want to be able to put a 3D imaging sonar. So we have an example of that. This is one of the commercial sonars. So this would be the piece that would be in the water, and then there would be a pole that would extend that down from the USV into the water. And I'll say about what we're showing here in all the systems, there's going to be additional hardware for the autonomy piece to put it down and put it up. In the price challenge statement itself, you'll see the exact specs for sizes that you need to consider, which will include both the equipment and the additional autonomy for it. So the next one we don't have a picture of, but it's a line arrestor payload. Christian, could you just talk? Oh, I'm sorry. The environmental. I'm going the wrong direction. Environmental payload. For those of you who know anything about sonar, the sound speed is varying on the temperature of the water. So knowing the temperature of the water in the water column will tell you a lot about how your sonar will work. So there's systems like this that if you dip it in the water and bring it back up, you know what that profile is, and you can optimize your sonar based on that profile. So we'd have a system like that, again, with the autonomy to put it down and bring it back up. Acoustic towed array. So I'll talk about this one because it's something I actually understand. So towed arrays are these long things that they tow behind ships or submarines. Sometimes they're on the bottom, where they're used to acoustically detect anything going on around them. The array that we'd probably use is actually in the water, but some examples are this orange array down here. And to give you an idea of what it would look like on the back of the USV, it would be on a reel like that, again with a motor to bring it in and out. So the line arrestor we don't have. Could you just describe what a line arrestor looks like?
So maybe talk net first.
Okay.
Yep.
So if you could just talk about the net, sure.
So the net, what you see here is a net launcher. This is an early prototype we used for a non-lethal defeat of UUVs. This is a fold-out section that gets mounted to the back of an arcade. Originally, it was a manned security boat. The net is underneath the cover in the back. You can see that orange parachute, which I'll hold up in a second, and that is almost like a sea anchor, right? Like a drogue line. So you would fire that off, in this case manually deploy it. We have more advanced options where this is pneumatically launched, picture like a t-shirt launcher. That sea anchor into the water, and it would unfurl the net, and now you've created a movable barrier to grab a UV. A variation of this would be the same type of sea anchor with just a line on it, a lot like a lobster pot line. So if you can get that close to a prop on a vehicle, you can foul the prop and you could disable the vehicle. So these are the non-lethal side of that. And give me a second, I'll hold up this drogue line.
As he's doing that, I think we've hit all of the different payloads that we'd expect the USV to handle. Okay, so capabilities. Won't get too much into the details. That point out a couple of things. We're looking at harbors, not deep ocean stuff. We want to be able to operate in Sea State 3, survive Sea State 4, and we're looking at speeds of up to about 6 knots with the array deployed. So just all these sensors that we talk about dipping and coming up, that's not when we're moving, except for the towed array. So that'll be dragging behind the vehicle, and we have in the challenge statement what the equation is for that drag when you look at your power requirements. When you look at the endurance, we have the 4 knots without the array deployed, 48 hours at 4 knots, and 12 hours at 4 knots with the array deployed. So you have 2 kind of options there when you're in search mode. When you don't have the array deployed, there will be a burst capability we'll be looking for of 25 knots. And if you look at that, there's probably very little time to be going at speeds in between. So you'll be tooling around at a slow speed, but then you might have to hit the gas and go to that faster speed. So something to consider. Again, electrical engineer, but when you're looking at your hull designs, something like a hydrofoil might work, where you'd normally not in hydrofoil mode, but you hit the gas and that gets you out of the water. Even any planing hull, where it's kind of slow and dirty until you hit a certain speed, and then you get up into the planing mode, and things go fast. I'm going to spend a little time talking about the cost of the system, because we want it to be a challenge, not only the how you're approaching the problem, but even how you think about the problem. We didn't want to say, hey, it should cost this much. We want to look at it as a cost for 50 missions. This thing could be solved with a vehicle that's really cheap, but it only lasts 1 mission. Or it could be solved with something more expensive and last 10 missions, or it could be even more expensive and handle the whole 50. So it's this balance between the cost of the vehicle and per mission and how many missions it could handle. So a couple examples that would meet this: if you had a 10K vehicle that could do just 1 mission and it melts at the end of it, so that 10 times the 50 gives you the 500K. If you could do 10 missions with 100K, so now you still get to that same 500K number, but your vehicle's lasting a little longer. So we want to give you the solvers a lot of design space in how you approach this when you look at how long the vehicle has to last. And as far as what we're looking for, we don't want a vehicle out of this prize. We don't expect for a $50,000 prize. You're going to be pumping out, all the companies will give us a vehicle at the end. So we're looking at preliminary CAD files, some hydro analysis, estimates of the weight. Make sure you have some analysis that it is seaworthy, can handle the payloads of the sea states, and then that it can handle the material strengths to have these systems attached. The main one you got to worry about material strength is that array will have some drag. The drag point will be at the top of the rail, so you're going to have some force on that. So you have to have at least something that's pretty sturdy for the back. So this is saying it's a theoretical challenge. So it's only a written proposal. And why you want to do this? Well, there's a cash award, which if you win that, hopefully you feel like it was worth the time and effort. And then if we have designs that we really like, The next step would be to go to a prototype of the system. And we would do that through a process called other transactions, which allows us to do something that's outside of all the government red tape. But this challenge will also serve as a source selection. So if we do that second step, we don't have to recompete. We can choose from any of the companies that have entered this and choose 1, 2, or whatever. So there'll be one cash award, but everyone will be considered as part of the source selection for the follow-on. And just as far as the rights, we're looking for non-exclusive rights. So let's say there's some high-profile event that people want to have some security at, or there's other uses for this type of vehicle. Go have at it. We're looking at just the rights for the Navy. If you want to do this for other industries, go for it. We're looking for those dual use, something that you don't have to rely on the Navy to keep the program going. If we don't award, there's no rights. So if people have had a chance to look at the details of the challenge, we do have that in slide form. If there's any questions, we can address them and bring that section on, or we can move on if people are okay. So any questions?
All right, thank you all for attending today. My name is Kelly Higgins. I'm a challenge design consultant for Incentive, and I will be covering basically how to participate in the challenge. You should be seeing my screen up right now, and I'll go through the process of finding the challenge and also participating in it, registering for it, registering as a solver for the challenge. So one place you can find the challenge is on incentive.com. This is the screen here. You can scroll down and see a number of challenges that we have running currently. See right here, this is the one today, the Harborside or the Waterside security. Click here and it will take you to the challenge page. You can also get to it from challenge.gov. If you come to challenge.gov, scroll down, you can find the challenge right here. Also click right there and it'll bring up the challenge page. At this point, if you've not signed in, if you're not registered as a solver, all you can see is the abstract and overview of the challenge currently on our website. Also talks about eligibility, about the seeker, and a few other details about the challenge. If you're interested in participating, of course, you want to log in or register. If you don't have an account yet, just go ahead and register for a new account. It's a free process. Ask for your first name, last name, the display name you'd like to use as a solver on the Incentive website. Once you do this registration, you're registered as a solver. You can look at any of the other challenges that are there as well. Ask you for an address, country, contact information. So if you do win an award, we'll be able to contact you easily. Password, and then you register. Once you hit register on this, they'll send a confirmation email to your email address that you provided at the top, and you click on that to confirm the registration and you become a solver. So I have an account already, a test account, so I'm just going to log in to this. So now I'm logged in as a user. You can look up here and see different aspects of your account. But now you still have to do one more step if you want to participate in this challenge. You need to view challenge details. Click here, and this brings up the challenge-specific agreement for this challenge. And this lays out the rules of the challenge. It talks about the IP treatment, your responsibilities in terms of making sure you're providing solutions that are yours to provide. You own the IP or you control the IP. Information about exclusivity period to allow the Navy to test or to actually utilize the solution, to evaluate the solutions. There are a few other details specific to this. in terms of a Navy challenge. In this case, this challenge is open to anyone in the world. It's not limited to U.S. citizens, as previous challenges have been. There are some restrictions in terms of U.S. federal employees, so you want to make sure you read through the details of this before you agree to it. Once you get down to the bottom, you hit agree, and it will take you to the details of the challenge. So now, what we saw before, the abstract and overview, are hidden. You can still see them if you click on this, but the main part of the challenge now becomes visible to you. You got background information, challenge, all the details that we've been talking about a bit in terms of what the requirements are for the shipping configuration, the in-water configuration, the payloads that it will have to deal with. Project criteria. This, of course, is very important. So you want to understand what your proposal has to include. This describes, a detailed description, CAD files, other information that you want to make sure your submission includes when you make a submission. If you want to make a submission, you can just go ahead and click Add Solution right here. And it will bring up the submission form. So you provide a name for the solution that's required. It can be descriptive. It doesn't necessarily have to be a solution abstract. So just a brief description of your proposal. The main piece of the proposal, though, is in the form of attachments. So down here at the bottom, you'll see where you will be able to provide attachments. So this is where you'll provide a written document that has the detailed description, drawings, any supporting information will then be provided as attachments. You can click here, pull up a file to include on it, and it will upload to our platform. There are certain file types that are accepted. If you're submitting drawings, types that aren't registered here, just zip them, tar them, do whatever to get them into an archive, and we'll accept them in that form. Once you've filled out the name, the abstract, if you want, you can do a conclusion. It's not required. And the attachment files that form the heart of the submission, the publish button down here at the very bottom will become active, and you can hit that, and it makes the formal submission of the challenge, or of the solution to the challenge. You can also save it as a draft if you want to continue to work on it. You can also discard it if you decide, no, I don't want to participate, but hopefully that is not the case in this. The process is anonymous from both sides, so the Navy, the seeker, will not know who you are when you make a submission. They won't know during the evaluation process. They won't have any details until the very end. If they decide to make an award and you receive an award, then we share the contact details for you with the seeker, so that they can reach out to you for any follow-on if there's a follow-on that's required or desired on the seeker's part. You can also form teams with this challenge. So every team member should be registered as a solver and also registered for this challenge. The team leader can send out invitations to the team members, and they can accept with the teaming agreement that's included. It lays out how the award would be split, things like that. And then once you make a submission as a team leader, so this is where we form a team. If you make a submission as a team leader, then the rest of the team members have to, or have 72 hours to review that submission, and they can provide comments, they can agree or disagree, but after that 72 hours, then you have to go back in and submit it formally once your team gets a chance to review it. During the course of the challenge, you can ask messages through the message tab here. If you have a question about the challenge, a member of the InnoCentive staff will address that, get an answer back to you as quickly as we can. Technical questions or questions about submissions, anything along the lines having to do with this challenge should be asked through the message center here. And the challenge is open as stated until September 13th. You can make multiple submissions here, but for something of this complexity, you anticipate that you will only be making one submission, but you can add more if you'd like. If you have very different ideas, very different design concepts, you can make multiple solutions and just keep adding different solutions here through this page. So that is how you participate. Very, very simple, very quick to do. And if you have any questions, I think you can ask them and they'll be conveyed through the chat for this session to me. And I will stop sharing at this point.
Great, thank you, Kelly. So Kelly obviously has joined us via Zoom. He can't hear us because the sound doesn't project well enough to get through the laptop sound. So we will be submitting questions that you have about the incentive platform to Kelly via the chat. But Susan has a microphone, and we ask that if you have questions for Steve and Christian, you ask them into the microphone so that we can record them so that they become part of the record of the event that goes out. And those questions will be transcribed and added to the incentive platform as well so that they're available to everybody who is potentially a solver. So if you have questions, raise your hand, and Susan will find you with the microphone.
Is there a requirement on how the data is transferred off of the vessel and back to any collection data point?
So that requirement will be handled by the Navy side. So as far as all the data collection, that will be part of the I want to say duct taped on, but that'll be part of the system that will be added to the platform. And actually, I think it specifies that all these systems will just have these different blocks with 4 I don't know, half-inch bolts or something like that. So it'll just be a bunch of landing pads for all this equipment, and we'll handle the data coming in and going out. How you doing, George?
Is all the payload that you described earlier government furnished equipment and not part of the $1 million budget? Over.
That's yes, that's correct.
Just a couple questions. Is the primary threat of concern subsea, or are we also concerned about surface and aerial threats?
For this challenge, we're focused on the subsea piece. As we add additional, if we add additional sensors for other threats, again, that'll be part of the Navy system. And we have, you'll see in the challenge statement, if you add up the requirements for each one of these platforms, it's less than the total that you need to support in terms of a vehicle for weight, et cetera. So we have some budget for additional sensors. They're just not detailed out at this point.
Okay, and then for you gave some speed requirements, but is there an agility requirement or a maneuverability requirement? Being a turn radius or things like that.
We do not have those specified. And it probably would have been a good idea to specify it, but they're going to be pretty subtle because you're going to be in this kind of search mode. You're kind of cutting the lawn or going back and forth, and then when you're in a sprint mode, it'll be going to a waypoint where you might have to have some turns, but we'll be looking at things for far enough out that a gradual turn will be able to get you to that waypoint.
Okay, and then my last question is, I understand this challenge is mostly around designing this vehicle, but if we have ideas for the autonomy or maybe some alternative payloads that are functionally equivalent, is it worthwhile to put those in the proposal, or would that not even be considered and is just a waste of space?
We have the evaluation criteria kind of spelt out. So it wouldn't affect the prize challenge itself, but if you have that information through either connecting to the 401 Tech Bridge or connecting to me directly from the Northeast Tech Bridge. You can find the information on how to connect, and I can give out my email as well. Getting us that information just for future reference would be worthwhile. And then there's also a broad agency announcement that Newark has for looking for new ideas. I'll just give a general warning on that. If that idea comes in, we both have to think it's a great idea and have funding for it. So a lot of times we see a great idea, but then it's going to take us some time to find the funding. So the requirements to put in that BAA are pretty light. You can even do a PowerPoint presentation. But it just kind of gets the information flowing. So if we wanted to have a full proposal, we could look for that, or we could kind of put it in and say, all right, let's try to find some money for this next year. Similar to what I talked about with the this prize challenge, if you put something into the BAA, that satisfies a competition requirement because it's your idea pushed into the government. We can't use that if we have something we want and we're asking for it. But if it's just a general idea that you push in, that would satisfy competition requirements, and then we could look at different funding avenues outside the prize challenge.
Thank you. Just for clarification, 2 questions. The deliverable as part of the application, is the expectation to review design concepts, ideas, or is the expectation is to review CAD drawings that can actually have been analyzed already to 80% confidence factor can provide the intended solution? That's the first question.
Okay.
And the second question is, what is the actual price, dollar value for the effort?
I'll answer the second one first while I think about the first one. So it's $50K is the prize. So to answer the first question, so the CAD drawings are conceptual, so we don't expect to do do some structural analysis or anything like that. It'll be kind of our engineers will look at them to say, okay, this is reasonable. They might do some analysis based on the drawings. Hydro analysis, it would be first cut based on the shape of the vehicle. Things like buoyancy, we'd expect you to have that nailed, at least within a certain period based on the size of the vehicle. But we're not looking for a CAD drawing to the level that we're going to build the thing the next day. And we're looking for the ideas that it's like, oh wow, I never thought of, using drop stitch technology to hit a button and inflate it, or I never thought of, having a couple platoons that fold out. We're looking at that kind of level to say, hey, this is a cool idea, this will work, and based on this CAD drawing, it looks like they've identified the right amount of space, they have the right amount of buoyancy. It looks like it'll go through the water with some reasonable hydro performance, and looking at the propulsion versus whatever the estimated drag is, say, okay, it should meet the mission with this much gas or this much. I love electric motors, but with this much battery. And by the way, being electric is not part of the evaluation criteria. That's just my personal.
What's the expectation of ground support, meaning getting the unit out of the container, assembling it, and launching it?
Ooh, that's an excellent question that I will not answer.
So when we deploy the system expeditionary now, we typically have anywhere from 4 to 6 people, and then we have logistics support, which could be a forklift, overhead crane. Specify all that. A lot of kind of a loose going in requirement would be 2-man portable for a lot of the components, and then maybe you assemble them into something bigger is typically how we do it. A lot of the sites, you assume certain things, like there's some sort of a sport boat and a forklift or a crane to get the system into the water. Or a trail or something. Yeah. So I think some reasonable. I think the easiest way would be to put those in the assumptions, right? And that way it would allow our guys to take a look at that.
Yeah, my question is, are you only using one of these on site? Or when you go to a location, do you need multiples?
So one concept is we have the one vehicle doing everything, some environmental survey with the blue view and the temperature sensor, and then entering its mission. The other concept is you have a tag team where one might do part of it, do the environmental sensing, and the other do the actual search. Either case, having a backup would be nice, since we are talking about potentially designs that aren't going to be as robust as a traditional vehicle. So if something snaps, having a backup would be good. So that's why the requirement is one, the goal of two. It kind of makes us feel better about having that backup and the flexibility to do multiple missions. And one thing when we talk about, you had asked the good question about putting this thing out, as you envision in your mind, you can envision, let's say one of our carriers or somebody is out and they have a problem where they have to come into port. But they're not close enough to a Navy port, but they're close enough to a friendly port. So they pull in, you have the crane, you have some boats, you have some support, but they don't have the security systems to protect the asset. So then Christian puts on his cape and they shoot him over with his shipping container, sets up the system, and now they're protected. Or that may be going on in parallel or to the ship coming in. So you go from a friendly port that's unprotected to a friendly port that is protected.
Considering this would be deployed in unknown regions, is there a requirement for propulsion, jet versus prop?
That there is not. There may be some advantages to one versus the other, but we're looking at assuming that you have enough depth that you're not going to be hitting the depth, and you're in a port situation where you're going to be able to go where the boats are normally going and not have to cut through seaweed or something like that where other propulsion might help. The one thing when you look at autonomy systems tying into propulsion, some are easier than others. So a diesel versus an electric, electric, you connect a couple wires, you're good. I'm not sure about some of the jet, but I think it's similar. So there are some kind of secondary advantages to other propulsion systems, but right now we just want to get something out there and work, because our autonomy system can connect to all the different types of normal propulsion systems. George.
Thanks, Susan. So as I understand it, there's no specific requirement for fuel or energy source that can be left up to our imagination. Is there, going down that path, should we assume that within this Connex container, recharging, refueling, whatever needs to be part of that system?
That's right.
So fuel source travels with the container.
Right now, if it's battery, we'd expect it to be part of it. I think you could probably make the assumption that we can get gas. It may, if you just put those assumptions in there, that'd be good. There's probably other issues with shipping of fuel that would probably be a bigger deal than the size and weight for the fuel. I'll refer to what the spec says. It's laid out in there for, and the endurance is tied to. There's different endurances based on speed, so there is a various mission profile. So if you are thinking electric, how long you have to be out there, you have to meet those two speed profiles.
testing and do the environmental testing and kind of an all-in-one product?
Yep. Yep. So all these things need to be bolted to the unit, and I'd say anything under the water line would be kind of a quick in and out and not affect your drag profile, with the exception of the towed array, which, you know, there is an equation in the challenge statement of that versus speed, and you could use that for two things. One, seeing what kind of propulsion you need, and also understanding the strength requirements of the array mounting.
Okay.
Back on that question, correct me if I'm wrong here, but if the requirement is 48 hours, check the spec on that. I think that could be one vehicle. That could be, say, 3 vehicles running 16-hour op tempos, right? Is that
Yeah,
correct?
but for the challenge itself, there is a requirement
For
based on
48.
one
Okay.
vehicle.
One vehicle. Okay.
So things like that. So we are noodling about other ideas. So so there may be, depending on the results of this challenge, either a follow-on challenge, or maybe we learn enough from the prototype. Say, hey, this design was something that we might want to dig into a little bit more. But it might be better if we had two. Yes, sir.
Is the container a full load or half load, or?
So the requirements in there specify the size of the container and the size of the reserve, which all this stuff will fit in. So we specify the size required, and we ask it to be contiguous, so we can put these things together. What I've done, just to make sure that our requirements aren't out of whack, is to in that space, if it was all against the back, say, we would have enough space to fit all this and stack it within the requirement we have in the spec for spare.
Is the ASUV assumed to be fully loaded and choose the payload to use at the site, or the payload will be used before it gets deployed?
So we expect the vehicle itself to have no payload on it in its shipping configuration. And it'd be part of the assembly process. Do we have, I know we had slides that actually had all the details of the statement that we could probably. So the expectation is you've taken up a portion of the shipping container for your vehicle. The rest of it is all this stuff. You pull it out, you bolt them all the pieces on, you put it on the trailer, and then you go, and you reverse that process on the way in. And then if we kind of cycle through as we find those slides, I'm just going to touch on something that was said earlier about teaming. That's something that I find really exciting. You know, I know some of the capabilities of some of the companies here to have a composite company talking to a drop stitch company, or a electric power motor company talking to a boat builder in the region. Having that teaming, and I'm a federal guy. I live in Rhode Island. I'm a federal guy. I don't really care who comes up with it, but I would just love to see some local companies come up with some really cool ideas and have this thing running around in Narragansett Bay. So when you're on your sailboats or you're out fishing, you can say, hey, I designed that thing with this guy down here in Charlestown and this guy here over in Portsmouth, and I think it's a really great opportunity for the region to wow. There's someone I used to work with that anytime, I have a PhD, and anytime someone would walk into the room with a PhD, she'd throw them a piece of chalk, and if you dropped it, they'd say you're a PhD. If you caught it, she wouldn't believe you. So, so as you look at this shipping container, you can see that reserved volume. And again, we don't want that to be kind of scattered throughout, so it does have to be a contiguous volume. And trailer any tools or equipment. So, you know, we have logistics support, but we don't want to be looking for the right hex screwdriver. You know, so whatever equipment is needed for assembly. And then you have the shipping weight, and then the production within 2 hours. So a part of that will be just screwing on the platform. But the main thing we're worried about there is if you have a large assembly process to put the vehicle together, to make sure we could do that in a reasonable time. Early on in some of these challenges, we were looking at potential for added 3D printing of parts. But when we get into this particular mission with 2 hours, really not too much I think you could do there, but we're certainly open to that technology. And you see each one of these will come up with, each platform has its own size, weight, power requirements. The interface, you'll see there are all a bunch of plates with 4 bolts, and then any special constraints. I thought I had something in there for the oh, here we go. So yeah, it does 48 hours with the 4 knots, and so if you can meet each one of those, we'll be able to kind of have a combination of those to complete a mission. So hopefully that answered the question. It has to hit each of those, but not sequentially. So if we ran it for 4 knots without the array deployed, we'd expect it to be able to do it for 48 hours. If we had the array deployed, we expect it to handle 12 hours. And then if we were going without the array deployed at 25 knots, we want to be able to do that for 6 hours. In actuality, the mission would have some combination of those, but we've worked out the budget here that you can bounce between them and it'll work. So you're only required to look at each of those 3 and solve those three requirements. So as we wrap this up, for anyone who's worked at Newark, we don't have our own money. We have to go out and find money to give for projects. So I do want to do a shout out to our sponsors. So down at NAVC, down in DC, NAVC 05, Ben Buffard is a really forward-looking program manager down there. He's the one who really wanted to do prize challenges. He's been funding this challenge and a previous challenge. So, you know, if you don't want to do a good job for the Navy and for us, do a good job for Ben, because he's the type of person we need in the Navy, and his team, Scott, Ryan, our local guy, Lewis. They've been great in terms of having the Navy think a little bit differently, move a little bit faster than we tend to move, hopefully a lot faster than we tend to move, and be more welcoming to business. I always say, you know, you go to Newark, you see a gun, a guard, and a gate. We're not a welcoming bunch of guys. We want to be working in a place like this. We want to be interfacing with you guys. We want to be teaming with the guys you know and trust already, like Mary and Christian. I hope you trust him. He has me fooled. And Lee is like amazing interfacing with people. So even if you don't like working with the bureaucracy of the Navy, you have to like working with these guys. And with some guys on the inside, like now CO5, who want to do things better, we hope to make it a good thing to work with DoD again. And really, we need the help. You know, China moves fast. Our threat countries move fast. They don't worry about competition between their companies as much as we do, which slows us down. So, and they have a lot of people. So we need all your help. Thanks. The flag was supposed to be flying.